morning, everyone.
Good morning.
Any questions before we start? I got some lovely email. That might shock some of you. Dear Professor Robert, with due respect, I am writing this mail to ask you regarding the selection of my research paper for coursework 1. Is it fine if I go with this paper? Viz 30K, a collection of figures and tables from IEEE Visualization Conference publications. Yes, that is okay. That paper is fine. Yeah. Any other questions about anything, coursework 1 or 2? Okay, good. If you do have any questions, you're welcome to ask anytime. You can interrupt at any time. Yeah, just raise your hand. So we're going to give a brief introduction to so-called qualitative methods for research. So if you can remember from the last 2 weeks, 2 weeks ago we gave a brief introduction to quantitative methods for research. Right, we looked at like a brief introduction to statistics, very, very common. And then last week we looked at visualization. That is the subject of coursework 2, by the way. And today we turn our attention to a different style or the next category of research methods. These are all, by the way, these are all evaluation methods. They're like methods that are trying to provide evidence to support your hypothesis. Usually your project involves a hypothesis and you need to produce some evidence that supports or refutes a hypothesis. So these are 3 different classes of techniques, right? Statistics being one category, visualization being another category of evidence, and then qualitative methods being another category of evidence or methods. So we're looking at qualitative methods. If we see this prefix quant, it means it's numerical, it's associated with numbers, right? Integers, floats, those sorts of things. If we see the prefix qual, it's usually not to do with numbers. Actually, it's usually associated with natural language text. Usually, not always. Or things that can be observed but not necessarily measured. Sometimes we try to turn qualitative data into quantitative data. That's usually what happens, actually. But this is what we're going to talk about today. That may sound very mysterious, and it is a little bit mysterious based on what I just said. But hopefully we're going to clear that up. And there are also so-called mixed methods, right? Mixed methods involve quantitative and qualitative evaluation, right? And they can be any combination, right? Linguistic variables or fuzzy concepts, and we're going to talk more about this today. That will make more sense after today's lecture, hopefully, and next week, by the way. Okay, so I'm going to try to just draw your attention to these terms, data, information, and knowledge. Right? We use these terms, data, information, and knowledge, a lot, right? So how do we obtain knowledge? How do we increase our knowledge of the world? That's ultimately what we're trying to do, right? We're trying to expand our knowledge of the world. That's ultimately one of the reasons universities basically, that's basically why they exist, right? So we're trying to increase our knowledge about computer science, right? Computers and software. Maybe about something that we're going to design or something we're going to create, right? For your projects, right? You're going to create something, right? And you hope that you learn something, that you hope that it contributes knowledge somehow. And maybe you study about people and their interactions with the technology in its role in their life. Here are some different approaches we can use to obtain knowledge, like increase our knowledge through experiments, right? Could be a human-computer interaction experiment. Observation, that means just looking at somebody or looking at some interaction. You can also ask people, right? This is probably the most common way to obtain knowledge, right? Is you just ask somebody. So somebody wants to know about coursework 1, they just ask me, right, about coursework 1. We can try to create a simulation. So a simulation is a software representation of some behavior, and it's usually a simplification of the real world, right? But you can learn about the behavior of the real world through simulation. Looking at documentation is another common way to increase your knowledge, right? Reading, or looking at images, deriving mathematical proofs, and then of course designing and building, construction, right? Creating things. These are all different ways we can increase our knowledge. And I'm going to just, again, draw your attention to these 3 terms, that they're not exactly the same. So if we study these terms, data, information, and knowledge, in epistemology, all the epistemology experts agree that knowledge is valuable. However, to try to come up with a definition of knowledge, a formal definition, is very challenging, actually. So here's sort of some traditional definitions of data. Data could be defined as symbols. Information could be defined as data that are processed to be useful, providing answers to who, what, when, where, and why questions. And knowledge is the application of the data and information, providing answers to how questions. That's one perspective on the difference between data, information, and knowledge. In computer science, we can try to refine these definitions. Data being computerized representations of models and attributes of real simulated entities. Another way of thinking about that is symbols that are stored in computer memory. That's how I would think of that. Information, data that represents the results of a computational process, such as a statistical analysis for assigning meanings to the data, or the transcripts of some meanings assigned by human beings. So information is another way to say that is information is the human interpretation of the data. That's one way to say it. And then knowledge, data that represents the results of a computer-simulated cognitive process, such as perception, learning, association, and reasoning, or the transcripts of some knowledge acquired by human beings. Right? That's one way to think of knowledge. So you can see that whoever wrote this struggled a lot to define these terms, right? They're not easy to define. Another way of saying this is the application of computerized or digital information and data to solve a problem or apply it in some useful way. You need knowledge to do that. If you like this sort of discussion, if you think this is an interesting thing, you can read more about it here in full length, like trying to have a discussion about the difference between data, information, and knowledge. That could be like a coursework. Imagine a coursework where you had to write a report that makes the distinction between data, information, and knowledge. Does anybody know what the next level of the hierarchy is? There's a hierarchy of knowledge. Has anybody ever looked at that before? You can think of this as a hierarchy where data is at the bottom. We collect lots of data, and from that data we derive information, and then from the information we derive knowledge, and then there's something at the top of that hierarchy. Anybody ever look? Application? That's not the standard answer. That's not the standard top of the hierarchy. Anybody else ever look at that before? The knowledge hierarchy? Yes. How did you know that? Nice. Wisdom is at the top. So it's like our purpose is to derive wisdom from, ultimately that's what we want, right? Wisdom. But then the next question is, how do you define wisdom? Do you know? Do you know the answer to that? How do you define wisdom? I don't know the answer. I don't know, actually. Maybe something like universal knowledge, like knowledge that's can be applied everywhere, something like that. Okay, so if we take a step back and we look at our different evidence gathering methodology or evaluation methodology, we can try to classify it, right? This is what we academics love, classifications. We love it. I love classifications. I love it, right? We try to come up with categories, and the categories are often two-dimensional, right? We have an x-axis, which is experimental evidence, observational evidence, reports and reflections, right? Documentation. And then on the y-axis, we have two categories, quantitative, right? These are things that are recorded numerically, right? Using numbers, right? It could be distances, times, memory usage, right? Energy, processing times. Things that can be measured and recorded. So in the experimental category, you have physical quantities, right? Could be velocity, for example. Could be response time. We have observational measurements, right? Eye tracking can be used, by the way, is one of our computer science methodologies. Questionnaires using scales and numbers. This is a very common kind of quantitative approach to gathering evidence using questionnaires. I think everybody here has filled out a questionnaire before. And then we have qualitative approaches, right? And qualitative approaches usually involve natural language processing, or natural language. People just thinking out loud, or saying something, or writing something. It could be a user study in an artificial setup or a laboratory setting, supplemented by observations or think aloud protocols where a person is telling you what they're thinking. It could be ethnography. So ethnography is when you observe behavior, you watch somebody do something, like get money out of the ATM machine. I don't know, like, I see ethnography, or I observe people in daily life. I don't think of it as ethnography, but I notice that I observe people, and I conduct experiments in my head as I'm observing them. Like, does anybody here go to Subway? The Subway by Lidl?
Yeah.
Have you ever noticed everybody struggles with the door? So if you look really, really carefully at people going through the door at Subway, and it's not just Subway, it's everywhere actually. It's not just Subway, but for some reason, Subway, like if you're at Subway, you have nothing to do but watch people going in the door. But if you look really careful, it's a very good human. It's not human-computer interaction, but it's more like human furniture interaction or human like doorway interaction. Most people get it wrong. They grab the door and they push instead of pulling. Like they make an attempt to get through the door. It doesn't work, and then they make a second attempt to get through the door, and then they do it again on the way out. Right? So that's like an ethnography experiment. You're just watching the behavior of people, and you could quantify it. Like I could sit there with a notebook and pen and say, okay, I actually kind of do this in my head. I think like, wow, the last 5 people all got it wrong, right? Most people get that door wrong, even both ways, including myself, by the way. And it makes you wonder why. Anybody know why? There is a reason why people get the door wrong. If you look at the door design is flawed. That's the reason actually. So like you can design a door with pull interfaces and push interfaces. If it's got a handle you can grab, that's a pull interface. That's telling you to pull. So if you have a handle like this and you have to push it, that's a flawed interface. That's all over the place. All over the place, those kinds of flaws. And that's what makes this problem of not just Subway, but it's all over the place. And you see push interfaces are just the panels on the door, right? But you see it all the time that there's a push interface and maybe a handle. So you push first, it doesn't work, and then you pull the handle. That's another flawed interface. Anyway, I'm getting off on a tangent. But that's ethnography, and I notice that I perform a lot of ethnography experiments in my daily life. I watch people and watch the things that go wrong, and then think, oh, I wish I could call the manager of Subway and tell them that their door is flawed. And then you can also watch the reaction of people when they make the error. Like, how do they react, right? Because people have different reactions. And then, of course, there's interviews, right? You can interview a person and say, like, why do you think you couldn't open the door to Subway? And see what they say. I never went that far. And of course, there are other ways of gathering evidence. This is not the only ways, right? Mathematical proofs, examining written and material evidence, so researching, simulation, research through design and creativity. Simulation is probably best put here, right? This is where simulation would fit. Okay, so before you undergo or to conduct any experiments or kind of evaluation, you want to plan it ahead of time, right? So you want to identify what it is you are investigating. Have you written down any clear hypotheses or questions you are trying to answer? This is the introduction of your dissertation, by the way. This is the introduction section of your dissertation. What questions are you trying to answer? What hypothesis are you trying to confirm or refute? Or what are you trying to gain an understanding of? You're trying to increase your understanding of something, right? It's good to have those things written down before you start your study. Are you concerned with outer actions or inner behavior? Do you want to see how a person will do something? Do you want to know what they are thinking or feeling during it? So depending on the answers to these questions, your study, the approach that you use in your study will change, right? Are you going to look for evidence in specific categories, or are you open to what participants say and then generalizing? So basically, how specific is it? Is what you're looking for very specific, or is it very open and general? A really good experiment will try to actually have both aspects. There will be some very specific things that an experiment is trying to understand, but there'll also be an open-ended aspect that lets new information in that's unexpected. And it's always good practice before you run any sort of an experiment or a test to run a pilot study. So imagine you're running an experiment and you want 20 people to participate. You do not conduct a study with 20 people like immediately. You do not do that. You conduct a pilot study with 2 or 3 people, see how it goes. Like, is that study running from start to finish in a successful way? And then you conduct the full study. But usually you run a pilot study first. You find out that there are some things that need to be improved, and then you run the full study. Okay, so this is not going to apply to every dissertation, by the way. These are some general introduction to the topic. So some dissertations will not have user studies or many people involved, right? But if you do have people involved, how are you going to get access to those people? Like, how are you going to get other people involved in your project? Like, how are you going to motivate them? And when you do find people to participate in your evaluation, are they actually representative? Can their behavior be generalized to a broader audience, like to a broader set of users? So many studies are about generalization, right? If we observe 30 people using some software, can we then generalize the results to the wider population, right? Will these observations apply to subsequent users, right? Is that true or false, right? That's an open debate, right? That's not a black and white question. This is one of the biggest mysteries in all of computer science, and not just computer science, but I think especially in computer science. How many people do you need to be involved in your experiments before they're generalizable to a wider population? It's a very big debate. Some people think the number is very small, and some people think the number is big. One rough guideline, by the way, is we have enough participants when we start to see the same results and observations over and over again. When the results and observations start to repeat, then we know we're getting close to the amount that we need. How do we avoid unwanted biases, right? They could be demographic, right? It could be biased. There could be a gender bias, an age bias, a race bias, an educational bias, geographical or political bias, right? A lot of studies are the study of undergraduate psychology students, right? So all the studies in computer science are undergraduates in computer science or master's degree students in computer science. And whether or not that's the findings from such a study can be generalized to the rest of the world is a big question. Right. Okay, and then after your study or your experiment, you've gathered the data, you've collected data presumably during your study or your experiment. It could be a human-computer interaction study. It could be just a software performance study, right? You're building a piece of software that you think is faster or more accurate than other pieces of software. So you've gathered your so-called information. How are you going to turn that into knowledge or so-called findings or results, right, to support your hypothesis or answer your question? You might need to do some processing, right? You might need to turn a voice recording into text, like digital text through a transcription, right? The data is usually anonymized. You might need to summarize the information, or the data, rather, that you've collected. We have lectures. So the lectures from last week and 2 weeks ago are essentially about this, how to summarize the information. You can summarize it in statistical methods, or visualization. Visualization is such a great summary, isn't it? You can summarize billions of numbers in a single image and then see that image in 5 seconds, right? If it's text data, it might have to go through a so-called coding process. And that means looking for themes, reoccurring themes that appear over and over again. So in trying to extract honest representative quotes from interviews, right, is evidence. And sometimes you have unusual comments that are outliers but are still very insightful. And there are tools, by the way, that help with this coding process. Right? Imagine you've interviewed 20 different people and you have 20 transcripts of interviews, and then your head just explodes like, oh my gosh, how am I supposed to process all of this text? I have 200 pages of text, and I need to somehow look for patterns in there, try to extract new knowledge from these 200 pages of text, these interviews. Like, how is that possible, right? That's what this coding process is about, and there's a piece of software called In Vivo to do that. Or there are multiple software tools to help with that. So this is just one example of a survey, right? A survey technique. Why did you not take your medicine as the doctor requested you to? And then the patient gives some sort of a reply. And then you have to analyze those replies. Can anybody think of a good way to analyze these replies? Imagine you surveyed 1,000 people and you wanted to summarize the results of that survey. Can anybody think of a good way to do that in this example?
Group them.
Group them?
Yeah.
How?
Go to the answer and count the numbers. Each thing.
That's right. A histogram.
Yeah.
So you just plot a histogram of the answers. That would be a very, very good starting point, right? From our visualization lecture. This is a screenshot of the In Vivo interface, right? It's a tool that you can use to assist with the coding process. Imagine you have interviews with 20 different people. Look, and there's a list of 20 different people. You can go through the text. This is a manual process, by the way, so it takes time. And then you highlight certain things, and then you assign those texts to certain themes. You try to characterize the text, like this person is talking about this subject, right? and they make this observation, and so on. And you can see there's a color coding here for each theme, right? And so there's a category here called natural environment, there's a category called economy, infrastructure, and so on. So this person is going through and trying to pick out the reoccurring themes and derive some new information, right? That's the coding process. In vivo is probably the most popular piece of software for that kind of analysis. Okay, so after you conduct an experiment or you build a piece of software or whatever you've done in your dissertation, you're looking for patterns, trends, outliers while you're examining your evidence, right? And can you see any patterns, right? Are there any trends, right? Are the data that we've collected supporting our hypothesis or addressing our question or answering our question or increasing our understanding of the world in any way? Usually that's what patterns and trends and outliers help to do, is increase our understanding. And then I'm going to try to explain these two terms, inductive and deductive. How helpful this is also up for debate, but these are very, very common terms used in research methods, just like qualitative and quantitative. Qualitative research is often described as inductive. What does that mean? Patterns emerge by looking at the data and developing a theory. You could call that bottom-up. Inductive is bottom-up, going from very specific data. You can think of data at the bottom of a hierarchy, if you remember that hierarchy, and then trying to derive information and knowledge. So going up the hierarchy, data, information, knowledge, wisdom. Unfortunately, we never get to the wisdom part. But that's the inductive category of research. And that is opposed to the so-called deductive. Quantitative research is deductive. Deductive is top-down. We start with a very specific hypothesis or a specific question or a specific conclusion, and then we test that theory quantitatively, testing an existing theory or a hypothesis. And that's often sometimes called top-down, going in the other direction. So at the top is some knowledge, and then we look for the data that supports that knowledge or that theory. It's looking down, or top-down. And this is trying to show that in a diagram, inductive versus deductive reasoning. So inductive, we start with a specific observation, and then we try to look for patterns and draw a conclusion. In deductive, we start with a theory, we formulate a hypothesis. These are kind of the same, really. Then we collect the data, analyze the data, and see if it's consistent with our previous hypothesis. Okay, and then we'll wrap up with sort of 5 common generalizations that are often applied to qualitative research. Even you might have noticed that whenever I say qualitative, I have to pause for a second before I say it. So I guess the word qualitative and quantitative, those two words they're stored in my memory very close together. So it's very easy for my neurons to fire and retrieve the wrong one. Quantitative research is objective, whilst qualitative research is subjective. That's an interesting generalization. That's what some people think, right? Quantitative measures of physical quantities have a consistency and reliability that reports and reflections don't have. I mean, there is some truth to that, right? It's nice to be able to sit back and measure things objectively without, let's say, listening to somebody's opinion, right? But there's usually some subjectivity to that process too. What do we choose to measure, right? There's some subjectivity in this question, like whatever I'm choosing to measure is subjective, right? And if I choose to measure something, then I'm also choosing to leave out other things. So what you include in your measurements and what you exclude from your measurements is also can be subjective. Similarly, once we start analyzing qualitative data, we can use labels and categories that give it an over-formal sense of objectiveness. So we can convince ourselves that what we're doing is objective, even when it's not, right? If we start to use categories and labels, we can fool ourselves into thinking what we're doing is objective. By the way, when I discuss these generalizations, I'm also pointing out the times when the generalizations don't work, right? For every generalization, there are exceptions. Right? Generalizations have big limitations. Qualitative research is about discovering ideas, whereas quantitative research is about testing them. So yeah, qualitative research is usually more open-ended than, say, quantitative research, because quantitative research is usually measuring something, right? And you have to decide what to measure beforehand, right? Usually. A common approach in qualitative research is grounded theory. You investigate a broad topic through interviews, focus groups, observations, and then form theories that explain your observations. So in grounded theory, you're gathering data, but you don't know what the results are going to be ahead of time. You don't necessarily have to have a specific hypothesis ahead of time. You're just gathering as much information on a topic as you can. And then you form theories from that observation. So that's in contrast to starting with the hypothesis first and then seeking out specific data to confirm or refute that hypothesis. But it's not an absolute truth, right? You can have a qualitative study that begins with a very specific hypothesis. That's also very possible. Another common generalization is one of the first things that we need to decide is whether a study is qualitative or quantitative. That is usually true, but the best studies have aspects of both qualitative and quantitative. So if you're, let's say, observing a user as they perform a task, you're measuring a very specific quantity usually, which is performance time, how long it takes somebody to perform a task, and the accuracy, like how often are they getting it right. So like going through the door at Subway, right? When I'm looking at people going through the door at Subway, I'm measuring the accuracy. Like, do they get it right the first time or the second time? I've even seen people do 3 times, like pull, push, pull, like 3. And then you're getting the accuracy and the response time. How long does it take? Like, some people do it very fast, like push, pull, really fast. And some people, like, they do a push, and then they're like, whoa, and then they do a pull, right? So you're always measuring the accuracy and the response time. But if I was going to do a really good study on the subway door, I would ask people, like, hey, I noticed you had a problem going through the door. Like, why do you think that is? You know, and then I might get more information that I didn't realize I was getting. Right? And so a simple questionnaire can be also used to derive some quantitative data, right? And some free text answers can be used to get some quantitative, qualitative data, open qualitative data. Sometimes a study might start with something qualitative, like an interview or a survey, and then conduct a quantitative experiment based on the results of the qualitative portion. So, generalization number 4 out of 5, quantitative research is about making measurements of what is happening, whereas qualitative research is about asking people's thoughts and opinions. That's generally true, Sometimes good qualitative research can begin by asking people to talk carefully through what they are doing and to contextualize it, and then draw findings from this description. Right, so these are just some examples, right, of that process. So that's it. You can think of that as one kind of generalization for these when you're gathering your evidence. Quantitative research is driven by theories, whereas qualitative research is driven by stories. That's a interesting generalization. There could also be cases though where theories in qualitative research too. There are theories in qualitative research too. Some of these exist prior to the study, and some emerge during the study. Right? And oftentimes, quantitative research can be the result of stories or things that have happened, and expectations that have been sort of formulated through experience. Sometimes we can see an odd quantitative measurement, but then we need to come up with a story to explain it, which can lead to the development of a theory, right? So that sort of phenomena happens repeatedly. And then one bonus one that I added, my own experience. Quantitative research studies numerical data, whilst qualitative research studies natural language data. This is how I think of it. If you're trying to analyze numbers, you're dealing with a quantitative experiment or quantitative research. If you're studying and trying to derive new knowledge and information from natural language text, you're in this qualitative mode, let's say, of research. And then, of course, there are exceptions. Qualitative data can be turned into numerical data and vice versa. You can change these. You can derive qualitative data from natural language data and vice versa. It's possible. Okay, so just to sum up, quantitative methods are usually working with numerical data, whereas qualitative methods are usually working with natural language data. Any questions about this topic so far? So that was a very, very general introduction to qualitative methods, and we're going to talk more about qualitative methods for research next week as well. I think I wore everybody out. Okay, you're free. You're free to go. If you're happy, you can go. If you're unhappy, you can stay here until you talk to me until you're happy. Yeah.